Hello, I saw your question in the email. For accompanying data set, draw a scatter diagram. That's this first part. Here's the data set. By hand, uh, compute the correlation coefficient, and that's what we have here. And then part C, determine where there's a linear relationship between X and Y, and that's what these critical values are for, to answer that question. So first part, I'm guessing you probably don't have trouble plotting points. I mean, you just got to match it. 2, 4, you just come over to, looks like they're counting by ones here on this axis and twos on this axis. So for 2, 4, you'd come over 2 and then go up 2, and right there's 2, 4. So I know it's not this one because, it doesn't have a point at 2, 4. Now this one here, that does have a point at 2, 4, so it's possibly it. So you just need to look and see if the graph has these 5 points on it, 2, 4, 4, 8, 6, 10. And this one does have 2, 4. I couldn't show all the graphs in this info too. So I'm guessing you could match the graph. Next they say compute by hand. Now you can use technology, but it is good to work an example by hand before you jump on the technology. And so that's, don't just follow the directions here. I know I worked some in class. You can go back and review that video also. Now these numbers here, I did change them here. I do have 2, 4, 4, 8, but 6, 13, 6, 15, and 7, 17. I mean, these numbers differ a little bit from yours, particularly the Y values here. I want you to do your own work, so I changed them up. So here's the formula for determining R. And so to use this formula, you need to know the mean for the X's and the standard deviation for the X's, and also for the Y's. And so here are the X values, and here's the Y values. So I come over here, to get the mean, you just add the values and divide. You got 5 of them, so the mean for the X's is 5. And I just use StatCruncher technology. The standard deviation is 2. Then you need to come to this column, you need to add those and divide by 5. I get 11.4. And again, I just use StatCrunch to get standard deviation. That's something we've already covered. So we've already covered this part. This part of the formula. And these are z-scores, and that's something we've covered too, what's in the parentheses. And so now you want to take each value minus the mean over standard deviation for X and Y. So I do one example here. So you take the particular score, 2, minus the mean over the standard deviation. The mean standard deviation for X are here. So 2 minus the mean, 5 over standard deviation, that's negative 1.5. So that goes there. And doing this in a table is probably the way to go. Now I put this in red. What you got to do is put 4 in there and 6, both the 6s, of course you get the same answer, and 7. So you want to take all 5 of these values, place them here, subtract 5, and divide by 2. And these are the numbers you would obtain. Of course, these are the same since it's 6, 6. Now you want to do the same thing with Y. You take the particular value, 4, and the mean is 11.4. You subtract the mean, and you divide it by standard deviation. So I did the first one, negative 1.3910. Then you got to do it for 8, 13, 15, and 17. So you got to, instead of 4, you got to put in these other values, and this is what you'll get. Now you want to multiply these two numbers. This is find z-score for X, z-score for Y. Hopefully that looks familiar. Now, this is new here, multiplying each of these pairs of numbers, and this is what you get. Now you want to add those numbers. I mean, that's what the formula says, the sum of the product of z-scores. Then you want to divide by n minus 1, and there's 5, 1, 2, 3, 4, 5 pairs of data. And so you get, for this particular example, R is 0.987. Of course, you've got slightly different numbers here, so you're going to get a little different R. So that's part B, doing it by hand. Part C, determine where there's a linear relation. So what you want to do is compare R to the number in this table. And so N is how many pieces of data you have, and we have 1, 2, 3, 4, 5 pieces of data. So for us, I've been calling it C, I guess, in class. C is 0.878. and you want to compare that to R. If the absolute value of R is greater than C, and that's the case here, 0.987 is greater than 0.878. If R is greater than C, then we say there is a linear relation between them. So just comparing what's in this table to what you get in the previous part. So that just comparing two numbers, that shouldn't be too bad. Hope this helps.